we are going to solve this convolution sum problem. So we are given x of n. So x of n equal to 2 to the n u of negative n and h of n equal to u of n minus 2, for example. So we wanted to compute the output y of n, which is x of n convolved with h of n. So we could write the convolution sum as sum k from negative infinity to plus infinity x of k h n minus k. So let's substitute x of k and h of n minus k here. So x of k, right? So we know that x of k, I can put on the side here. So x of k is 2 to the k u minus k, and h of k, h of n minus k, is u n minus k minus 2. So when I substitute those in this summation formula, so we have 2 to the power k u negative k, and the h is u n minus k minus 2. So if we wanted to do this analytically, then we have sum k from negative infinity. So I'm going to break it down. So first of all, we need to take care of the unit step functions. So u of negative k, we know that is 1 when negative k is positive. That means k is less than equal to 0. So k less than equal to 0, that means the summation goes from negative infinity, right? Because it's negative infinity less than k less than 0, because k is less than 0, k must be a negative number or equal to 0. So k from negative infinity to 0, 2 to the k u n minus k minus 2. So we are going to take care of the second unit step function. So u n minus k minus 2, we know that is equal to 1 when n minus k minus 2 is positive. So that means n minus k n minus 2, n minus 2 is bigger or equal to k. Okay, so if I call this condition 1 and this condition 2, so let's take a look at what happens. So we have the discrete time axis. So we have this. So this is 0, minus 1, minus 2, minus 3, minus 4, minus 5, and so on. Now, so k for condition 1 Well, we have k that goes from negative infinity up to 0. And then for condition 2, that depends on n. So we might have this scenario where we are somewhere here. So n minus 2 is less than 0. So case 1, we have n minus 2 is less than 0. And case 2, when n minus 2 is bigger than or equal to 0. Right? So I wanted to make sure that I indicate this. It doesn't matter where, if we close and open here, put it like that. Right? As you're going to see at the intersection, the values are going to be the same. So and I'm gonna elaborate more on that later on. So for this case, so what do? So the overlap, right, we need to take the intersection. So the intersection is from k from negative infinity, right, sum k from negative infinity to n minus 2, because that's where the overlap happened. Okay, so 2 to the k. So then that gives me 2. So I'm gonna use this formula, and then I'm gonna talk about that formula in a minute. So 2 to the negative infinity minus, so in general, let me talk about that before we go. So in general, when you have sum from n0 to n1 of alpha to the power k, so that's alpha to the k, alpha to the n0, right there, minus alpha to the n1 plus 1 divided by 1 minus alpha. Okay, so then that gives me 2 to the negative infinity minus 2 to the n minus 2 plus 1 divided by 1 minus 2. And this condition is n minus 2 less than 0. Okay, so let me insert some space here. Now, then this give me 2 to the power negative infinity is 1 over 2 to the infinity, which is 0, minus 2 to the n minus 1 divided by minus 1. So we are in discrete time, so n minus 2 less than 0. That means n is less than 2. But in discrete time, that means n is less than or equal to 1, right? If you think about it, we have 2, we have 1, we have 0, we have negative 1. So n is strictly less than 2. That means it must be at least, at most, equal to 1, right? So n is less than equal to 1. So for this case, we have y of n equal to 2 to the n minus 1, n less than or equal to 1. Okay, so then for the second case, when n, so we have this scenario, so we have 0, So that's case 1 is k less than or equal to 0, and the second case we have n minus 2, right? K less than or equal to n minus 2. So the intersection is here, right? So for that case, we have sum k from negative infinity to 0 to the k, and that gives me 2 to the negative infinity minus 2 to the 0 plus 1 divided by 1 minus 2. So it gave me negative 2 over negative 1, so that's 2. So for this case, y of n is equal to 2 for n minus 2 bigger or equal to 0. So we can write this as a piecewise function. So it's 2 to the n minus 1 when n is less than or equal to 1, and it's 2 for n minus 2 bigger or equal to 0. N bigger or equal to 2. Excuse me. So I can also write this. You are equal to 2 to the n minus 1 when n minus 1 less than or equal to 0. It's 2 when n minus 2 is bigger or equal to 0. So which is essentially y of n equal to so here we have n less than n minus 1, yeah, less than, okay. So I can write this also as 2 to the n minus 1 when minus n plus 1 is bigger or equal to 0, and then 2 when n minus 2 is bigger or equal to 0. So here I wrote it in this form, so then we can write y of n equal to 2 to the n minus 1 u negative n plus 1 plus 2 u n minus 2. Okay, so we could either have this. All right, so let me copy this. I'm gonna paste it down here. You write it like this. So I don't know what form you prefer, but then you have, if you write it as a piecewise function, that's what it is. But if you write it in terms of the unit step function, this is what it is. Thank you.